Okay, let's continue section 2.2 video, part 3. And we want to pick up with this same equation that we left off with in the last video. I want to show you a couple of other things before I give you that very important note. It's this. Look at this circle right here. If you will notice this circle, it appears that the center is right there, doesn't it? Now, what is right there? It's the ordered pair 0, 0 in this case. Now, notice something else about this circle. Remember in geometry, whenever you're talking about the radius of a circle, what did we say the radius of a circle was? It's how far the circle is away from the actual center. So if you measure from here to the circle, that many spaces, that's what your radius is. Well, if you measure from here to over here, that's 1, 2, 3 spaces. 1, 2, 3 spaces, etc. So it appears that the radius of this is 3. Now, I'm going to show you something that's absolutely not going to make sense exactly just yet, but it will. So just stay with me here and keep watching. Look at this equation of the circle. First thing I want you to notice is this. What power is x to? It's to the second. What power is the y to? It's to the second. One of the distinguishing features about every circle is this. The x will be squared and the y will be squared. Now, not only that, notice what's in front of the x squared right here. A 1. What's in front of the y squared? It's a 1. What's in front of the x squared and y squared is the same number. It turns out, I'm going to give this to you in a note in just a minute. It turns out that that is the distinguishing feature about every circle is this. You're going to have an x squared term and you're going to have a y squared term in every one of them. Now, question. Behind this x, do I have any number behind this x right here? No. There is no number. Another word, the number we use for no number is the number 0. Is there a number behind the y? No. There's no number behind the x. There's no number behind the y. So that's 0, 0. Now, look at where the center was located. 0, 0. Now, next question right here. Look at this number over here. 9. If you get the square root of that number, what do you get? 3. 3 was your actual what? Was your radius. I'm headed somewhere with this, and I'm almost there. Just bear with me just a little bit longer. We call x squared plus y squared equal 9 the center radius form of a circle. So in other words, every circle, if it's in center radius form, is going to have an x squared term, it's going to have a y squared term, and there's going to be a number over here. Now when I say an x squared term, there may be a number behind that x. There's not in this one, but there may be a number behind the x, like a x plus 3 or a x minus 7. There may be a number behind the y, but it's still going to be squared. So you have an x squared term, a y squared term. Now it turns out that if there are any numbers behind this x and y, that affects where your center goes. Remember in this one up here, was there a number behind the x? No. Was there a number behind the y? No. So the center was at 0, 0. And then this number, so these two numbers affects where the center is located. This number right here affects what your radius is. And we get the radius by taking the square root of that number. Now, I'm going to show you a whole bunch of examples. I'm almost there, so stay with me. I promise it'll make sense once I get all the way through this. Just got to give me a few more minutes. All right, so let's take down this note. Here's the note. The equation of a circle is in center radius form if it appears as the following. And then here it is. All right, just write this down. So, every circle, if, that's the key, if it's in center radius form, you will have an x squared term plus a y squared term, the numbers in front right here, both ones, equals, and then there'll be a number over here. All right, now, I told you that sometimes there's a number behind here and sometimes there's a number behind the y. Let me make up two letters to put behind that. Now, you remember I said just a minute ago, I said the number behind the x and the number behind the y are the two numbers that affect where your center goes. Let me explain why now. Here's what you do. Whatever is behind the x, whatever's behind the x, take the opposite of it and put that in the x spot. Whatever's behind the y, take the opposite of that and put that in the y spot. And that'll tell you where your center is located. Let me make up an example. I'm going to do a bunch of these with you, but let me just make up something right quick. So suppose this was x minus 3 squared. This would be plus 3. X minus 7 squared. This would be plus 7. X plus 4 squared. This would be negative 4. X plus 10. This would be negative 10. So this is the opposite of that. Now you say, Mr. Rayner, what if there's no number there? Then the h is 0. So the h is the opposite of the number behind the x. You say that again. The h is the opposite of the number behind the x. Now the k is the opposite of the number behind the y. For instance, if this is y minus 7, this would be plus 7. Y minus 50, this would be plus 50. Y plus 11, negative 11. Y plus 4, negative 4. If it's just y squared, then your k value is 0. So that's how you can get the center just by looking at it. And by the way, that's why this is called the center radius form of the circle. Now, how do we find then the radius just by looking at this? So let's do that. Radius. You find the radius by taking the square root of whatever's on the end right here. Well, if you take the square root of r squared, you would just get r. And by the way, the reason we use the letter r there is for r stands for radius. All right, so here's what I'm going to do. It's okay if you're still confused. It's okay if you still hadn't got it. You will get it once I get to these examples. So here's what I'm about to do. I'm about to give you a bunch of circles that are in center radius form. You're just going to write them down, and you're not going to have to touch them at all. And what we're going to do together is, just by looking at them, how do we get the center and the radius of every one of these circles? Now, let me get a little ahead of myself. You say, Mr. Trader, why do we want to know the center and radius of all of these circles? Because in order to graph any circle in algebra or geometry, the two features you must know before graphing any circle is you got to know where the center is located. Otherwise, how are you going to draw the graph? Where are you going to put the circle? So you got to know where the center's at because it locates where it's going to go. But you also have to know the radius because the radius is how big around it's going to be. And we'll talk about that in just a minute. Okay. So I think I'm at my examples of where I want to be, where I think I can explain this where you'll understand it. Just don't panic. Give me a shot at explaining it here. Okay. So write down these instructions. For the following equations, state the center and radius. For the following equations, state the center and radius. Now remember, what's the center? It's the h, comma, k. So in other words, find h and find k. And then find r. Because if you find h, k, and r, you have essentially found the center and radius. So the instructions you just wrote, I could have said find h, k, and r. That's the same question. All right, so here's what I want you to do. I want you to copy these problems down. And after you get these copied, we will, give me just a second. Sorry, hang on with me just a minute. I'm just trying to space this out. So. I'll tell you when to pause the video. I just got to get it all hid right quick. Okay, so what I want you to do, let me make sure you got it all on your screen. Okay, yes. All right, I want you to pause the video now. All right, I'm assuming you paused the video, and I'm assuming that you already have copied all of these. All right, so just kind of sit back and watch now for just a second. All right, here's what I want you to notice first of all. You don't have to write this one up at the top. All right, remember this is the center radius form of the circle. X minus h squared plus y minus k squared equal r squared. All right, here's what I want you to notice about every one of these. From 1, 2, 3, 4, 5, 6, 7. In all 7 of these problems, I want you to notice some things. First, do all of these have an equal sign? Yes. Next question. Do all of these have 2 letters in it? A X and a Y. X and a Y, 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 X and a Y. So yes, they all have an X and a Y in it. Next question. Are all of the x's and all of the y's squared? Yes. X squared, 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 and all the y's squared, 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 and squared. So in every one of these problems, you have an x squared and you have a y squared term and you have an equal sign. So every one of these problems are what we call center radius form of the circle. All right, so here's what I want to do. I want to state the center and the radius. Now, what is another way to say state the center and radius? Another way to state that is say state h and k. All right, what did we say h was? We said h was what was behind the x. It's in front of the square, but behind the x, the opposite of it. So in this problem right here, there's the x. Here's your h. It's in front of the square, but behind the x. So in this problem right here, your h is positive 3. It's the opposite of it. What is your k? Your k is the opposite of this. So h is a positive 3. K is a positive 5. Now, how do we get the radius? The radius, you take the square root of whatever's on the end. So question, what is 9 squared? What is 9 times 9? It's 81. What's the square root of 81? It's 9. So in this one right here, the h is 3, the k is 5, and the square root of 81 is 9. All right, so let's do this one. What's h here? Positive 4. What is k? Positive 8. What is r? Which means radius. It's the square root of that. What's 10 squared? 100. What's the square root of 100? It's 10. Okay, let's do this next one. What's h? Positive 3. What's k? Positive 1. What's the radius? The square root of 16. And what's the square root of 16? It's 4. So h is 3, k is 1, r is 4. Now this one. What would h be? Negative 5. What would k be? Positive 2. And then the square root of 25 is 5. Okay, right here. What's h? Negative 1. What is k? Negative 3. And what is r? It's the square root of the number that's on the end. Square root of 49 is 7. Now, this next one. You said, well, there's no number behind this x here. That's right. Remember, if there's no number behind the x, it's 0, not 1, because it's being added and subtracted. So right here, the h right here is 0. Now the k is positive 1, the opposite of that. The k is positive 1. Now let me say again, I don't have to list it k. I could list it as an ordered pair, and that's what I'm about to do in just a second. I could list it 0, 1 for the center, and I'm about to do that. All right, in this problem right here, what's your h? There's no number back here. It's 0. What's k? There's no number back here. It's 0. What's r? The square root of that number, which is square root of 4, which is 2. Okay, now, let's keep going. Let's do 4 more examples here. Sorry, give me just a second. All right, but this time when I do these, I'm not going to list it as h and k. I'm going to list it as center and radius. So let's do this one. All right, now I'm just going to call it center. But remember, this is h and this is k. What is the h in this problem? There's no number behind the x, so it's 0. There's no number behind the y, so it's 0. And then the radius is the square root of 81, which is 9. No, that doesn't have to always be a whole number, but it will be for us, particularly the ones we're graphing. All right, let's do 3 more and I'll have to stop the video. How do I know this is a circle? X is squared and the y is squared. All right, how do we get the center? The center is h, comma, k. What's h? It's the opposite of what's behind the x but in front of the square. There's no number there, so it's 0. K is the opposite of what's behind the y, which is a positive 3. And then the r is the square root of 16, which is 4. 2 more. Okay, center. H, comma, K. First, how do I know this is a circle? Because the x is squared and because the y is squared. All right, what's the center? The h is the opposite of what's behind the x, but in front of the square. So that's x plus 1, so the h would be negative 1. Y, there's no number behind the y, so it would be 0. That's your h and your k. And then the radius is the square root of the number that's on the end, which in this case is square root of 4, which is 2. One more example here. Center, h, comma, k. All right, what's h? It's the opposite of what's behind the x, but in front of the square. So the h is positive 3. K would be the what's behind the y, in front of the square, the opposite of it. So y would be negative 5. And then the radius is always the square root of whatever number's on the end, which in this case is square root of 100, which is 10. So this is how you get the center and radius of a circle if, that's the key, if it's in center radius form. And so by the way I'm saying that, that should imply to you that they're not going to always be in center radius form. And that is correct. They will not always be. But all of the ones we've looked at so far have been in center radius form. All right, we'll continue with the center radius form of a circle in the next video.